state the principle of superposition for second order ODEs, verify this for the ODE, ordinary differential equation. So let's write down second order linear homogeneous ODE. That will be then P some y double prime plus Q y prime plus R y equals 0. Okay, if the principle of superposition says if y1 and y2 are two solutions of star, then so is their linear combination. So C1 y1 plus C2 y2, where y1 and y2 are arbitrary constants. Okay, now we need to verify this for this ordinary differential equation. Okay, so we need to find two solutions, and then we need to show that a linear combination of those two solutions is also a solution. Okay, so here the given ordinary differential equation ODE is y double prime minus 5y prime minus 6y equals 0. Now we can solve this by finding characteristic equation, which is we just take r square minus 5r minus 6 equals 0. Now we can solve this quadratic equation. So r minus 6 r plus 1 equals 0. So r equals 6 and negative 1. So then y1, so y1 first solution is e raised to 60 or negative 1t. It does not matter which one is which. 60 is one solution, and y2 is e raised to negative 1t or just negative t. So these are two solutions, okay, of this given ODE1. Now we'll find a linear combination of these two solutions and show that linear combination is also a solution of 1. Okay, now we set y be a linear combination of these two. So C1 this plus C2 this, okay, a linear combination of these two solutions. And now we need to show this is also a solution of 1, equation 1. So how do we show that? We simply plug this y into 1. Okay, we just plug in 1 here, and we have to get left hand side is equal to right hand side. So this has to be 0, so that 0 equals 0. So look at here in equation 1, y is this, but we also need y prime and y double prime. So let's find y prime, y double prime, plug in here, and we have to get 0 equals 0. Okay, so this is y, then y prime derivative is 6c1e60 plus this is negative, so it will be negative 1 e to the negative t, and y double prime is now 6 times 6 36 c1 e60 negative 1 times negative positive c2 e to the negative t. Now plug these into 1, so we get y double prime, that's here 36c1 e raised to 60 plus c2 e raised to negative t, that's y double prime. Now negative 5 times y prime, so we need to multiply this by negative 5 and right there. So negative 5 times 6, negative 30, c1 is 60, negative 5 times c2, negative positive, so 5c2 e to the negative t. Okay, and finally negative 6y, so we need to multiply this y by negative 6. Okay, so negative 6c1 e to the 6t, negative 6c2 e to the negative t. So that's the left hand side, and we want this to be 0. Look at 1, equation 1, so we want to get 0. So I'm writing, is this 0? Okay, let's see. Here C1, C1 and C1. This is 36 minus 36 minus 6, 0. So these three cancel, by the way. Okay, in the same way, C2, 5C2, negative 6C2. C2 plus 5C2, 6C2 minus, so they also cancel. So that is, yes, 0 equals 0. Okay, so this is how we verify the principle of superposition for this particular ODE, but this works for any ordinary differential equation, second order linear homogeneous. Final.